Okay, here we are once again. We're going to have a look at Open Virtual Switch as part of a virtualized software-defined network environment. I've built and used virtual switching environments such as Mininet for the purposes of testing. I've also built some virtual switches as well. What I'm going to build here is an open virtual switch on a physical device, and that physical device is going to be the Raspberry Pi. Now, the Raspberry Pi, as you probably know, doesn't have much in the way of ports, but what we're going to do is we're going to use the Pi 2 or Pi 3 Model Bs, where they have 4 USB ports, and we're going to use USB to Ethernet adapters together then with the 5th port, which is the original Ethernet port, and that will give us plenty to play with regards to switching. So physical switching using OVS. So we need to get the OVS software down to and loaded onto the Raspbians. Now if you're starting from scratch, then you'll need obviously an image. If you've already created an image, then of course all you need to do is just clone that or copy that image and then go in, change a few things around networking and maybe the host name, and the job is done. We'll have a look at some of those a little bit later on. So we'll start off with a Raspberry Pi that's blank and then build that up. So this has got a feature as part of a sort of a bigger project, and that bigger project sort of builds out 3 Raspberry Pis. That's my project, and all 3 of those were built essentially from the original image that I created in the same way as we're going to do over this and the next couple of videos. But what I also added was a fan, or fans, because there's one on each layer, and also a shutdown button, because that's one thing that's lacking on the Raspberry Pi, is the ability to safely shut it down. You have to go sort of log in and shut them down via software. Good old sudo shutdown and the likes. But what I've done here is just written a very simple script, and that script is engaged when we see a certain condition on one of the GPIO pins. We also use the other GPIO pins to control fans by measuring the temperature on each of the Raspberry Pis and then independently turning their fan on or off. So what I've got here is I've got a stack, an acrylic stack with sort of metal rods in between, threaded rods of course, and they allowed me to create this stack of Raspberry Pis. They didn't come with a hole for the fans, some do, and if they don't, as in my case, then all I did was just lay out where I needed the fan to be, drill a few holes, and then use that acrylic layer as a template for the other layers, and just simply go along those. One word of warning: if you're drilling out the bigger hole using a hole cutter, remember it's acrylic, and acrylic doesn't like being melted. So I found out the first time I did that, so wasted a layer. I've got a layer 3, and that layer is where I'm going to put my SDN controller. In the future, I'm probably using something like Pox, could probably even try Open Daylight, see if that would work, but that's something for the future. At the moment, we're just talking about a Raspberry Pi being used as an OVS switch. So I create one image, and then I just basically go and copy that image once I've done all the necessary. The difference between the images, of course, is going to be the host names. So I'll go back and change the host names on those devices, and I'll also need to make sure that I've obviously got different MAC addresses. They should have, because they're physically different devices, and really sort of that's pretty much it. So let's get into it. So it's a Raspberry Pi 2 or 3 Model B, and as you can see, we've got this sort of stack. All of this stuff is available off sort of eBay or Amazon. And then what I've also got is these, on the right hand side, is these USB to Ethernet adapters. So the sort of full kit, if you like, the constituent parts, we're going to need a Raspberry Pi. We're going to also need some additional cabling as well, not least a power cable, for instance, which I haven't shown on here, using the sort of micro USB connector. We've got a USB powered Ethernet switch here, and the reason I went for USB powered is that I can use those sort of mobile phone charging blocks and make this sort of portable if I want to. So portable demo, not be restricted by the length of the cord to the nearest plug. I've also got a wireless keyboard and mouse combo, so we can see the USB adapter for that, which will plug into one of the available ports. Now we only do that to start off with, just to get some baseline config in, not least to get VNC configuration up and running so we can access the Raspberry Pi remotely, and then we can just disconnect the keyboard. I've also got a HDMI cable. Again, we'll only use that initially just to connect that up to a free monitor, get the Raspberry up and running, and then thereafter we'll network to it and use something like VNC to control it. We've got a powered USB hub, so that's got individual switches on there as well, so that I can switch on and off each and every one of those ports individually. And then finally, of course, we've got the 16 or 32 gigabytes micro SD card, class 10, so that's the only ones that I'll buy. And you can see I've got several of those, probably because I want to create 3 Raspberry Pis. Now 16 or 32 should do it. For what we're doing would be perfectly fine, just whatever you get out there on the internet. So as we said, we're looking at a Raspberry Pi. This happens to be a Raspberry Pi 3 Model B, and again we can see the 4 ports on the right hand side here and the Ethernet port underneath, so that the USB ports of course are stacked, so there's 2 and 2 in the diagram. And on the left hand side, just see sticking out there is the micro SD card as it's been plugged in underneath. So we'll obviously also need to connect power in, so that's that bottom left connector, and that's going to be using the micro USB. And then the HDMI will fit in here, where it's sort of labelled up above it as the HDMI input as well. So that's the sort of unit that we're going to be working with, and as I said, a Raspberry Pi 2 or a Raspberry Pi 3 should work. Other things we're going to need software wise, we can use Raspberry to order up the VNC. We can do that using Raspbian -config, and we'll also need some utility software on, so in my case on my Windows 7 laptop, which is where I'm going to be doing all of this stuff. So 7-zip, that will allow us to unzip the Raspberry Pi image when we download it from the repository. We'll see that in a moment. And also I'm using Win32 Disk Imager, which will allow me then, once I unzip the image, to then take that image and drop it down onto an appropriately formatted micro SD card through its appropriate adapter, of course. So as we said, we're using the GPIO pins on the Raspberry Pi, and we can see those numbered from pin 1 all the way through to pin 26. 2 slightly different variants here, depends upon whether you're using the chip settings. So that'll be the BCM or Broadcom chip, and they are identified as the BCMs 2, 3, 4 and so on. Otherwise we'll be looking at it from a perspective of being the sort of board pins, which is you can see here we either set the mode to GPIO board, and that's where we're using the pin numbers, or we set it to GPIO.BCM, in which case we're using the BCM numbers. So you can see how they sort of correlate. You can also see then that there are some that are defined as sort of power, so we've got the plus 3.3 volts, or the 2 pins on the right hand side which are plus 5, and we've also got the ground pins, which you can see are distributed across the pins. There's several encounters for ground, and then we can start using some of the pins. So I tend to use the sort of second column, if you like, and I'll be using sort of pins, if I need power, probably pin 4, ground pin 6, and then I'm using 8 and 10 in the sort of fan and shut down modules that we'll do sort of later on later videos. But those are the GPIO pins that you'll find on your Raspberry Pi. And there are the GPIO pins up there, and we can see in fact there's pin 1. Okay, so in this orientation it's the bottom left hand most pin of that set of pins. Good. Okay, and just make out on the actual board here it says GPIO anyway. Excellent. So first things first, insert the micro SD card into its adapter and then plug that in, and we can see here it's come up as H in my case. So checking that H is formatted. So let's look at the properties. We can see here it is in terms of the size of the thing. It's actually a 32 gigabit byte micro SD. Okay, so we'll right click on there, and of course we can format. So FAT32, that should be fine. Off we go, and that will take no time at all. Right, good. So we have a card in place, so that's sitting in abeyance waiting for us to go and get hold of our Raspberry Pi image. So we'll go off to Raspberry Pi, we'll download the Raspbian image, and that's the place to go. That's called Stretch. So we've got Stretch and Stretch Lite. The choice is yours. So we'll download the zip file. So click on that. It should go off and make a request, and then it should ask us if essentially, or come in just a second. There we go. Had a slight warning on that one from Raspberry that they were getting excess amount of traffic, and so we tried again, and there it is. So we can actually save that into our downloads folder, or I can go and create a folder in which I want to go and download that into. So I could change Raspberry Images, a folder that I've got, so I could now go and effectively open that up and then save it into there. Okay, so we open that up and we could save into here. In fact, I've already got a copy of that because I went off and downloaded that earlier, so simply save, and that will start the download for you. I've already done that, so I can simply go into that particular folder, and we can see that we've got that image in play. So there's all that sort of nearly 2 gigabytes worth of stuff. Now, if you go and try and extract that using Windows, it'll say it's got something like a petabyte's worth of data in there. So we're not going to use the normal Windows to unzip that, and this is where the 7-zip software comes into play. So if you just pull that up in, now obviously you need to go and download that, and you can see that I've already gone into the folder. So I just go back up here. I've gone into the folder within downloads into the Raspberry image, and we've picked up that file, so we've highlighted that file. So now all we need to do is extract that. So when it comes to extraction, we'll see this window pops up. We're okay to go, and away it goes, and that will then start doing the unzip. So we can see that now progressing nicely, and we'll just come back to that when that's finished. Right, so there it is. We've got our image. So let's go and look for that. So you see, here it is. There's the image, and we can see it's now nearer 5 gigs. So that's fine. Excellent. Sitting there waiting for us now to go and download using appropriate software, such as Win32 Disk Imager. So hence we've got that. Now you notice it selected the drive on the right hand side, and it selected correctly the H drive in my case. Check yours. And now we need to go and locate that image. So we'll hit the folder icon. Through downloads, of course, if you remember, it was in that folder that I put in here, Raspberry Image, and we can see it's under Raspberry Stretch, and there indeed is the image. So save that. We want to write to, and in future we can read from. So when we've created the image and then plug this into a Raspberry and load a whole load of other things, we can power down the Raspberry, unplug the micro SD card, put it back into its adapter, bring it across to here, and then we can, using the same software, read it, save that image, and that image then becomes the image that we copy off to the other Raspberries that we want to have the same facility, same functions. So let's write. So writing to a physical disk and correct, so yes to that, and it'll progress nicely in the background. So we'll let it do that, and we'll come back when it's a little bit more complete. So there it is, it's done, as it says it's done. So hopefully that's the case, so we can come out of the disk imager, and that's job done. So we've also finished with the zip file, but we can go and have a look on the H drive, where we should be able to find our particular image. Now notice that's disappeared from here, so we'll just have to do a little bit of a refresh. So just reinserting it, and we can actually see it's back on, it's here, there's the boot as it's called, and we can see now it's all sort of fully loaded. and this is where we are at. Now, it's interesting things around kernel and kernel 7. So for the different Raspberries, so you've got Raspberry Pi 1, the old A's or B's, and that uses the kernel dot image. And we see the Raspberry Pi 2 Model B, and that uses the kernel 7 dot image. And the kernel 7 is also used by the Raspberry Pi 3. So there we go. So across the range, it's the older ones using the kernel and the new ones using the kernel 7. So therefore, you may remove one of those images, because it's taking up space that you could otherwise use. I'm going to leave them there because I'm not as brave as you. Right, so now we've got the image. It's time, obviously, to safely eject our device. So that's gone, and we can then go and plug that into the Raspberry Pi. And we'll do that in a later video. Bye for now.